Hi, so I want to talk a little bit about this ransomware that's been going around and affecting health institutions lately. It's a variant on the same ransomware from a year ago, but it's basically the same thing. You know, when I start talking to people, some people think that data breaches or hackers are acts of God or natural disasters. But the truth of the matter is that hackers are not acts of God. They're just assholes. So I wanted to show you how these hackers actually work. The first thing that a hacker is going to do is he's going to find a piece of vulnerable software. In this case, he was using this application called JBoss. Now, JBoss is a relatively older piece of Java software. In fact, it's not even called JBoss anymore, so that kind of tells you how old it really is. But it doesn't really matter because the hacker is being opportunistic here. And so what he's going to do is once he finds his vulnerable software, he's going to scan the internet. And he's going to use this process, in hacker parlance, we call it banner grabbing. And so it literally just scans for servers on the internet that are running JBoss. This process can take a couple hours to a couple days to a couple weeks, depending on the type of software he's using. And once he gets his list, he can basically attack these servers immediately. Now he's using this other program called Jxbox, or maybe it's pronounced JXbox, I don't know. But you can actually find this on GitHub. That's the company that just sold to Microsoft for $7.5 billion. So you should ask Microsoft why they're hosting ransomware type enabling code. Anyways, Jxbox allows the hacker to launch what's called a shell. And this is where the attack really begins. Because once an attacker gets the shell, he can do all sorts of damage. And the shell is this little black box that you might see developers staring at all day. It allows them to do three important things. One, he can download new software to further his attack. He probably didn't bring along all of the software he needs to actually perform the attack, but once he gets a shell, he can download it. Number two, he can run other programs that were not meant to run on that computer. This is a pretty important one. Number three, he can use this shell as a landing base to attack other servers inside your eternal network. And so in this case, if it's JBoss, maybe it's connecting to a database that has PII information in it. And so we'll call it proxy. The reason he could do all these three things is because the operating systems we use today, mainly Linux and Windows, are designed to run multiple programs with multiple users. And this is all fine for end user laptops, phones, things of that nature. But in a server environment, we don't want that. In fact, developers go out of their way to isolate applications from each other in server environments today. And that's all fine and dandy, but point two is a real problem. Why would you let an attacker run his software on your server to begin with? What went wrong? How is this even possible? For that, we have to rewind almost 50 years ago. Back in the 60s, when these operating systems that use these concepts were designed, they were designed on very old computers. We're talking about the PDP-7 and the PDP-11. So these systems were designed to run were designed for multiple users, and by proxy, to run multiple programs. Why? Well, they were just too damn big. They were too damn expensive. Quite literally, these systems would fill up this entire space. Now, if you fast forward into the future, 50 years into 2018 when this film is being made, as mentioned before, developers are going out of their way to isolate their programs from each other. And they use virtual machines to do this. You know, many organizations will use, tens to hundreds or even thousands of VMs. And the key part here today is that it's virtualized. Because in today's cloud environment, whether you're using public cloud, you're private, or maybe you're somewhere in the middle with hybrid, it's probably virtualized servers that you're using. So here's the key takeaway, is that we don't need this concept of one server being able to run many programs on it anymore. You wouldn't want to do that anyway. It wouldn't even work because we have too much software nowadays. Unikernels prevent ransomware like this. Why? Because unikernels only run one application in one VM. And there's quite literally no other way to run other programs in that VM. There's no way to pop into the host, there's no concept of users, and there is no shell. There isn't even a way to spawn a shell because the system facilities don't even exist to do so. It's almost like having your own house versus living in an apartment with other people. And in this case, these are programs. So what's really interesting about this approach is that you could take and forklift this completely vulnerable JBoss application that you use to attack with JXBox, and you can put it into a unikernel. And then the exact same exploit does not work against it. Keeping your software up to date is definitely best practice, and that's good and all. But let's face reality, you don't have the time, there's too much software, and you just don't know what's out there. Unikernels don't stop all security problems, but they do stop ransomware attacks like this one, and they do stop assholes.